All right, my friends, let's take a look at problem 16. It says, what are all values of x for which the series, the sum as n goes from 1 to infinity, of the quantity 2 over x squared plus 1 to the nth power converges? For interval of convergence type stuff, which this is, you're going to have two go-tos. I would say the big stick, as in it's a lot more work, but it's very effective, is enforcing the condition of convergence of the ratio test. Which you could apply that here, but with this problem you could also fall back on something else that sometimes works, and that is if your series is geometric, which this one is. If in doubt, expand it out if you don't see what I'm talking about. But it's geometric and its common ratio is this base here, 2 over the quantity x squared plus 1. So if it's geometric, then you know that it would add up to something finite if its common ratio is between -1 and 1. And so since this is geometric, you're just going to basically take its common ratio, 2 over x squared plus 1, and it needs to be between -1 and 1. And so how do I want to solve this? I think I'd rather, instead of inequalities, I think I'd like absolute value for this better. Let's do this. Let's solve it like that. I think that'll be more fun. Okay, so that's another way of saying that it needs to be between -1 and 1. And then, let's see, and then from here, the absolute value marks are unnecessary. So we could just say, like that. It's positive, so it's obviously going to be greater than 0. Anyway, so you need this to be true. And then I hope it makes sense. If you want this fraction on the left to be less than 1, then that would mean that the denominator, x squared plus 1, would need to be something bigger than the 2 on top. So from here, that would mean x squared plus 1 would need to be something bigger than 2. And then I'm going to subtract the 1 over. So x squared has to be bigger than 1. And then totally up to you how you want to think this one out. But basically, numbers that you square and get something bigger than 1 would be numbers that are bigger than 1, or numbers that are less than -1. Another way to get that would be to square y or graph y equals x squared. To graph y equals 1, and then look for when the parabola is higher. So it would be from 1 and over, and then from -1 and out. There we go. Okay. Just if you can get here, you're good. Anyway, the answer ends up being D. Hopefully that makes sense. All right, problem 17, let h be a differentiable function and f be the function defined by f of x equaling h of the quantity x squared minus 3. Which of the following is equal to f prime of 2? I'm telling you, it's like your AP exam was written by people who hate it when other people forget chain rule. Anyway, so if you have a tendency to forget chain rule, cut that out. Anyway, so notice that f is defined as a composition of two functions. Your outside function is h. Your inside function is x squared minus 3. So when you go to take the derivative, so we're going to take the derivative, then we're going to plug 2 in. Make sure that, you know, you do that diagnosis piece and remember to use chain rules. So derivative of the outside function would be h prime. And then we're going to multiply by the derivative of the inside function, which would just be 2x. So f prime of x, I think it's a little cuter with the 2x written in front. So I just decided to take a whole line to rewrite it that way. And then f prime of 2 just means you plug 2 into the rule. 2 squared is 4. And so you get 4 times h prime of 1. Option B.